So it's finally time. In this video, what I want to do is show you what really ends up being probably the hardest thing that you learn in all of a Calculus 1 class. The challenge really doesn't come from any of the individual rules, the product rule and the quotient rules, for example, that we learned in this video. Where it comes is when you're using multiple rules within a given problem. You know how I'm always warning you to show all your different steps and be really careful of what rules you're using? The reason why is this video. So prepare yourself. This might end up being one that you have to watch a couple of times. What if you were asked to take the derivative of the log base 2 of x divided by 2 to the x power times x to the 5th power? The key thing to recognize here is that we have a quotient, something divided by something else. So we're going to use our quotient rule. But when we're using our quotient rule, at some point we're going to have to figure out the derivative of the bottom here. And to figure out the derivative of the bottom, since we have a product, we're going to have to use the product rule. I think what you'll see in this problem is that it's a product rule inside of a quotient rule problem. And this idea of nested rules is really challenging, but in kind of a strange way, kind of fun. Let's give it a shot. So the first thing to recognize is that we have a quotient, right? We got something divided by something else. So we're going to use the quotient rule. When we use the quotient rule, we take the derivative of the top, log base 2 of x, and we multiply that by the bottom, 2 to the x power times x to the 5th power. From that, we have to subtract the derivative of the bottom, so the derivative of 2 to the x power times x to the 5th power, times the top left alone, so the log base 2 of x. And then we're not done. Don't forget, you have to divide this entire mess by the bottom, which is 2 to the x times x to the 5th, squared. Using the quotient rule, the derivative of this quotient is equal to this expression. If you can kind of see the d over dx's and think about those as the work that still needs to be done, that can be really helpful. So I have two d over dx's. Maybe an overuse of color, but I'll show one of them in red and one of them in purple. The one in red won't be too bad. The derivative of the log base 2 of x, if you remember your logarithm derivative rules, then that is just 1 divided by x times the natural log of 2. This derivative in red is this expression in red. We're done. We want to take that and multiply it by 2 to the x power times x to the 5th power. Note, no derivatives here. And then subtract from that this derivative in purple. This derivative in purple is going to be a problem. Why? Because it's a product of two things, right? It's the derivative of something times something. To figure this out, you got to use a product rule. So this thing in purple is going to be some big answer. And once I get that answer, I'm going to multiply that answer by the log base 2 of x for this log base 2 of x. And then I'm going to divide that by 2 to the x power times x to the 5th power squared. What goes in these purple parentheses? Well, using my product rule, I got the derivative of 2 to the x times x to the 5th, which is just the derivative of the first thing, the 2 to the x, times the second thing, the x to the 5th, plus, for the product rule, the derivative of the second thing, the x to the 5th, times the first thing, the 2 to the x power. We weren't done up here because we still had these two different d over dx symbols. We took care of one of them over here in red, but when we tried to take care of the one over here in purple, we created two more d over dx symbols. So I still have two more derivatives to take. A lot of this stuff I can just leave alone. I got 1 over x times the natural log of 2. I'm multiplying that by 2 to the x times x to the 5th. From that, I'm subtracting. Be careful with your parentheses. The derivative of 2 to the x is 2 to the x power times the natural log of 2. And then I want to multiply that by x to the 5th power. And then I got to add to all of that the derivative of x to the 5th power, which is 5x to the 4th power, times 2 to the x power. And then don't forget this log base 2 of x that's kind of hanging out here. And then don't forget to divide this entire mess by 2 to the x power times x to the 5th power squared. Wow, that's kind of crazy. Could you clean this up some? Absolutely, if you felt the need. But frankly, I'm not going to bother. The reason I like to simplify these things a little bit is to show you how to rewrite things, but you won't need to rewrite anything that's quite this ugly, so I'd probably just leave this just like this. Maybe for the sake of time, I'll just put a big box around this and call it good and move on to the next one. In this next one, we're taking the derivative of log base 2 of x divided by 2 to the x times x to the 5th power. It looks really similar to what we have up here, but up here we have a product inside of a quotient. Down here I got something times something, a product, and inside that product, I got a quotient. This is a product rule inside of a quotient rule. This is a quotient rule inside of a product rule. If you can see that difference, you're doing really well with this very challenging topic where we have multiple rules nested inside of a given problem. Not sure if you understand it yet? Let me demonstrate. I'm taking the derivative of something times something else. So I'm going to use the product rule. The derivative is equal to the derivative of the first thing, the log base 2 of x divided by 2 to the x power, times the second thing, x to the 5th power, plus the derivative of the second thing, the derivative of the x to the 5th power, times the first thing, the log base 2 of x divided by 2 raised up to the x power. I got two of these d over dx symbols, so I have two pieces of work yet to do. One of them will be pretty easy. The derivative of x to the 5th, that's just 5x to the 4th. One of them will be really hard. Why is this really hard? Because it's a quotient. To figure out the derivative of log base 2 of x divided by 2 to the x power, I got to use the quotient rule. The quotient rule tells me that I take the derivative of the top, the derivative of the log base 2 of x, and then I multiply that by the bottom, 2 to the x power. From that, I need to subtract the derivative of the bottom, the derivative of the 2 to the x, times the top, the log base 2 of x. And then I got to make sure that I divide that entire mess by the bottom, 2 to the x, squared. This huge mess that I wrote in green is just this little derivative right here. It's not the entire answer. I have to take that whole thing and multiply that by x to the 5th power, and then add to that the derivative of x to the 5th power, which is 5x to the 4th power, times the log base 2 of x divided by 2 to the x power. As you see, these can blow up pretty badly and get really hard and kind of messy to write. Fortunately, the end is near because we only have two derivative signs left, and for both of them, we know the answer. The derivative of the log base 2 of x is 1 divided by x times the natural log of 2. That's this part. I want to take that and I want to multiply it by 2 to the x power for this 2 to the x. From that, I want to subtract the derivative of 2 to the x, which is almost just 2 to the x. I have to tack on a natural log of 2. This 2 to the x natural log of 2 corresponds with this derivative. I want to multiply that by the log base 2 of x. Make sure that you divide that entire thing by this 2 to the x squared. And then that's not your answer. That needs to be multiplied by x to the 5th. And then I need to add to that 5x to the 4th times log base 2 of x divided by 2 to the x power. Wow, that's pretty ugly. Could you simplify it? Absolutely. Should you simplify it? I don't know. I probably wouldn't. I mean, maybe I'd recognize I have a 2 to the x in each of these terms and factor that out and cancel it with this one. Maybe I'd even take this x to the 5th and distribute it through the parentheses so I could cancel this x with one of these x's. But I don't know, even if you do all that, it's still going to be kind of ugly looking. You can absolutely rewrite this if you feel the need. I don't feel the need. I'm going to call this my answer and I'm going to move on to another problem. This problem looks innocent enough, right? Maybe it doesn't look as bad as these ones did up here, but we saw how much these blew up. And so maybe based on how hard these are, you're a little bit cautious at looking at this and assuming it's going to be easy. If you have that caution, you're exactly right, because it's not going to be easy. But I think we can do it. First thing, recognize that we're taking the derivative of something squared. So you can think about that as the derivative of something, x cubed e to the x, times that something, x cubed e to the x. We don't know how to deal with expressions that are then being squared yet. So what we'll have to do is think about this as something times something so we can use our product rule. Our product rule says when you're taking the derivative of something times something, you take the derivative of the first thing, the x cubed e to the x, and then you multiply that by the second thing, which just so happens to also be x cubed e to the x, this one. And then to that you want to add the derivative of the second thing, so the derivative of this x cubed e to the x, times the first thing, also x cubed e to the x. You're like, all right, that's not too bad. Well, look, we still have to take the derivative of x cubed e to the x. In fact, we have to do that twice. And that's problematic because figuring out the derivative of x cubed e to the x involves the product rule because it's something times something. What I'm saying is to take this derivative, we're going to have to use the product rule. But we've already used the product rule. So really, this problem involves product rules inside of product rules. We've already done the outer, loosely speaking, product rule, but we still have to deal with the inner ones. The derivative of x cubed e to the x. That's the derivative of x cubed times e to the x plus the derivative of e to the x times x cubed. It was kind of hard to fit that all in, and you might be to the point where you can just figure that out without writing out that step. Maybe we could just take the derivative of the first thing, the 3x squared, and then multiply that by the second thing, the e to the x, and then add to that the derivative of the second thing, which happens to be e to the x, times the first thing, which is x cubed. This derivative is this mess using the product rule. That's not my answer. That's just one of the 4 parts that kind of make up my answer. I have to take that and multiply it by this x cubed e to the x. And then I want to add to that this derivative. But if you're clever, you might recognize that we already figured out that derivative. So that's the exact same as what I have written here, 3x squared e to the x plus e to the x times x cubed times this x cubed e to the x. As long as you're careful with your parentheses, this right here is the right answer. You can call that good if you want. I would probably go one step further. I'd recognize that this is identical to this. So really my answer is just taking something and adding to that the exact same something. I have one of these over here and another one over here. So I have 2 of these, x cubed e to the x times 3x squared e to the x plus e to the x cubed things. That's probably what I'd do. I'd probably rewrite this line like this, but you don't have to. You can call this good if you want and move on. Speaking of calling things good and moving on, I want to show you one more problem in this kind of intense video. And it'll turn out this example is super useful. This will save you a lot of time. I'm going to kind of give you a new rule here. In example 4 here, we're taking the derivative of a product of 3 things. Right? So far, we've only seen the product rule on 2 things. What if you have a product of 3 things? Well, there's a couple options for what you can do. The first option is just to add some parentheses. What am I talking about? Really, this is asking you to take the derivative of x cubed times e to the x times the log of x. So I could think about it as x cubed times e to the x times the log of x. It's tempting to look at this and be like, wait, wouldn't you have to distribute the x cubed to each of these terms? No, this is only one term. Because there's not a plus or minus sign here, this is all one thing. This is the exact same as this. These parentheses aren't doing anything at all. You may have learned long ago that there's this thing called the associative property, and really it's that property that allows me to put in these parentheses. You could look at this and recognize that this is equal to this, and then use the product rule. Right? You could take the derivative of the first thing, the x cubed, and then multiply that by the second thing, the e to the x times log of x, and then add to that the derivative of the second thing, the e to the x log of x, times the first thing, the x cubed. But if you did that, you're going to run into a problem in this next line. Right? I'll leave all this alone for now, the derivative of x cubed times e to the x log of x. That'll be a problem for later on. But over here, when I'm taking the derivative of e to the x log x, I got something times something. So I got to use a product rule. Might not look like it, but this is a product rule inside of a product rule. Product rule for this times and another product rule for this times. So let's do it. Let's see what happens. If I use the product rule over here, I would take the derivative of the first thing, the e to the x, and then I would multiply that by the second thing, the log of x. And then I would add to that the derivative of the second thing, the log of x, times the first thing, the e to the x. And that entire thing, so I better be really careful with my parentheses here, gets multiplied by x cubed. And you're like, cool, you can finally figure out your answer. You can take some of these derivatives. Actually, no, I'm not going to take any derivatives because I'm not interested in the answer. I'm interested in finding a more efficient way to do this. So let me show you a way you could rewrite this. This is all done. I'm happy with all of this over here. But these parentheses, maybe I can put them in red to make them a little bit more visible to you. I want to get rid of those parentheses because I really have 2 terms inside of those parentheses. So to get rid of these parentheses, I have to take this x cubed and distribute it to each of these 2 terms. So what does that end up looking like? From out here, I got the derivative of x cubed times e to the x log of x. And then if I took this x cubed and distributed to this one, I would have the derivative of e to the x times this x cubed and times this log of x. And then this x cubed hitting this last term would leave me with the derivative of, I'm kind of low on room, so maybe I'll write it down here, the derivative of log of x times x cubed times e to the x. Okay, this is really hard to look at, but look at what we ended up with. three terms. There's 1, there's 2, and there's 3. And each of those three terms have one derivative, the derivative of x cubed here, the derivative of e to the x here, and the derivative of log x here. And then they have the other two terms, e to the x log x cubed log x, and x cubed e to the x. What I'm saying is it kind of looks like there's this superpower rule. The power rule tells you that the derivative of f times g is f prime g plus g prime f. It kind of looks like if you have the derivative of a product of three things, f times g times h, you can do f prime gh plus g prime fh plus h prime fg. It's kind of the same as the power rule where you take the derivative of one of these things and leave the other one alone. It's just now there's three things, so in each case you're leaving two of them completely alone. Turns out that's entirely true. That's not a coincidence or something that I just came up with these numbers. That will always work. And this kind of superpower rule thing will be really beneficial in problems like this. You'll probably get to the stage where you can get this answer all in one step just by looking at this. You'd recognize that you have a product of three things. So you'd be like, all right, I got to take the derivative of the first thing, 3x squared, and then leave the other two alone, e to the x log of x. And then to that, I have to add the derivative of the second thing, so the derivative of e to the x, which just happens to also be e to the x, leaving the other two things alone, x cubed log x. And then finally, I'll take the derivative of the third thing, the derivative of the log of x, which is 1 divided by x times the natural log of 10. Because remember, when you write log of x without a base, there's an implied 10 right here. So it's 1 over x times the natural log of that 10. And then leave the other two things alone, x cubed e to the x. What I wrote right here in green is exactly what I would have gotten down here in pink if I took the time to evaluate this huge mess that took me several lines to get at. So the last thing I want to leave you with in this video is there's a superpower rule that works when you're multiplying together three functions. And it turns out that it doesn't stop there. If we had four things multiplied together, this still holds. You'd have four different terms, and in each of the terms, you take the derivative of one of those four parts, leaving the other three alone. It works for a product of any number of functions that you want, but in this class, rarely will you even see a product of three things, let alone more than three things.